Lesson 22, I will find factor pairs for numbers to 100 and define prime and composite. So you're going to see that there's three new vocabulary words that you're going to see today. The first one you're going to see is factor and factor pairs, and you're also going to see this word prime and composite. And today we're going to talk about all three of those words. In your math journal, I want you to go ahead and write today's date, and then I want you to write Lesson 22, factor pairs, prime, and composite. We're going to do quite a bit of writing in our journal today. Quite a bit, I guess I should say. Quite a bit more than we normally do. So I just want you to be prepared. All right, so the first thing I want you to do is you don't have to draw this. I just want you to take a look at this for a minute. You can see here I have an array, and you can see that this array has 1, 2, 3, 4, 5, 6, 7, 8 squares. So think to yourself, what would be the multiplication sentence that would represent this array? This is what you thought? 1 times 8 equals 8. And here's another array. Think to yourself now, what multiplication sentence could be represented by this array? 2 times 4 equals 8, right? So both of these arrays represent 8, but they represent 8 in different ways. That gets us to what we're going to be talking about today. 1 times 8 equals 8. 8 and 1 are factors. Numbers that multiply together to make a product are factors. So 1 and 8 are factors of 8. 2 and 4 are also factors of 8. Okay, so now we're getting to the part that I want you to put in your journal. I want you to go ahead and draw this very first array. You do not have to draw these squares. You can just come in and take your pencil and you can just simply make dots. I want you to notice that there are 18 of them. So you could just come through and say 1, 2, 3, 4, etc. You get the idea. And I want you to draw 18 of them. And then underneath that, I want you to record the multiplication sentence that this array represents. Put 1 times 18 equals 18? I hope so, because that's what it represents. Now I want you to draw this next array. So you're going to notice you've got 2 rows, and if you count, you'll see there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to have 2 rows of 9. And then beside that, I want you to write the multiplication sentence that that array represents. Hopefully you put 2 times 9 equals 18. So you notice both of these arrays equal 18. So if you remember from what we talked about earlier, 1 and 18, 2 and 9 are factors of 18. So I want you to label these. I want you to draw an arrow like this, and then beside that I want you to write the word factors. This is really important. This will help you to remember what a factor is. I want you to write the word factors, and then I want you to do the same thing here, 2 and 9, and I want you to write the word factors. Do this in your journal and make sure it's nice and neat so that you can go back and read it. All right, so we have 4 factors of 18, 1, 18, 2, and 9. Now I want you to think to yourself, can you think of any other numbers that you can multiply together that equal 18 besides 1 times 18 and 2 times 9? Hopefully you thought of this pair. Oh, not that pair. Hopefully you thought of this pair, 3 times 6. I want you to draw an array to represent 3 times 6. And then underneath this, we are going to write all of the factors of 18. And you'll notice when you see factors written, they can be written like this. These are called factor pairs. And the reason why they're called a pair is because there are 2 in a pair. And you can see that these are all paired together, 1 and 18 because they go together, 2 and 9 go together, and 3 and 6. But usually when you see factors listed, they're listed like this. So in your journal, I want you to list them this way. So 18, a colon, and then we list them in order from least to greatest. 1, 2, 3, 6, 9, 18. These are all the numbers that when multiplied together equal 18. Now, if you do not draw every time you go to list the factors of a number, you're not going to want to go through and draw all the arrays. That would take too long. So what you would do is you would think to yourself, okay, every single number has a factor pair of 1 and itself, so 1 and 18. So these two go together, so you can draw arrows to those two in your math journal. And then 2 goes with 9. And then 3 goes with 6. So if I were counting, I would say 1, 2, 3, and then there would be 4, 5, and then I would get to the next side here. Nothing times 4 equals 18, and nothing times 5 equals 18. That tells me that I got all of the factor pairs, or all of the factors of 18. Okay? So next, we're going to try to list the factors of 16. Okay? We're going to do this without drawing arrays. All right, I want you to think to yourself, what are some numbers that you could come up with that equal 16? So I want you to, in your math journal, I want you to put the number 16 just like this. Okay, so I just told you that every number has a factor pair of itself and 1, because 1 times 16 equals 16. So I'm going to put 1. 1 is the smallest factor of 16, and 16 has to be the largest factor of 16. Okay, so now I'm just going to try my counting numbers. So I'm going to think to myself, the next number after 1 is 2. So I think to myself, is there anything times 2 that equals 16? And the answer to that is yes. 2 times 8 equals 16. Okay, so those are both factors of 16. Now I'm going to think to myself, the next number after 2 is 3. And I'm thinking, is there anything times 3 that equals 16? Well, I know 3 times 5 is 15, and 3 times 6 is 18. So 3 is not a factor of 16. So next I go to 4. And I think, is there anything times 4 that equals 16? And the answer to that is yes. 4 times 4. So now if I wanted to draw arrows, I would say 2 to 16, 2 to 8, and then 4 to 4. And notice there's nothing in between 4, so I got all of them. Now when you list the factor pairs of 16, you would not list the number 4 twice. You would just list them as like this: 1, 2, 4, 8, and 16. Okay? One more little part in our journals, and we're going to get to our problem set, okay? All right, so now if we were going to list the factors of 7, the factors of 7 are 1 and 7. And then you think to yourself, is there anything else that I can multiply together that equals 7? And the answer to that is there is nothing. The only factors of 7 are 1 and 7. Some numbers are like that. They only have exactly 2 factors. The numbers that only have exactly 2 factors are called prime numbers. So in your math journal, I want you to write this: prime numbers. And then I want you to underline it. And then I want you to draw a line out beside it, and I want you to write this: exactly 2 factors. That means they don't have 1 factor, they don't have 3 factors, they have exactly 2 factors. That's what a prime number is. So can you think of another number besides 7 that's a prime number? Here's one. The number 5 doesn't have anything. Can you think of any other numbers that are prime numbers? Well, here's a couple: 11, 13, 17, 19, 23. 3 is a prime number. Any number that has nothing that you can multiply together to equal that number except for 1 in itself is a prime number. All right? Now, the other kind of numbers are called composite numbers. So I want you to write this in your math journal. I want you to write composite numbers. If a number is not prime, then it is composite. So the definition for composite numbers is that it has more than 2 factors. The last thing I want you to put in your journal is this: 1 is neither prime nor composite. I want you to think about that for a minute. In order to be prime, a number has to have exactly 2 factors. And in order to be composite, it has to have more than 2. Well, what number equal 1? The only number that you can multiply together to equal 1 is 1 times 1. Well, that's only 1 factor. So it can't be prime because it doesn't have exactly 2 factors, and it can't be composite because it has more than 2. So 1 is neither prime nor composite. All right, let's get to our problem set. I know that that was a lot in your journal today, but I think it's really important that you have that information in your journal, because if you get confused about what is prime, what is composite, and what is a factor, you can always go back and look at your journal. All right, so it says record the factors of the given numbers as a multiplication sentences and as a list in order from least to greatest. Classify each as prime or composite. The first problem is done for you. I love it when they do the first problem for us because that gives us an idea of what the expectations are. So you can see what they did. Here's how they recorded them as multiplication sentences, and over here they have their factors. They have them listed as factor pairs. So let's go ahead and do 6. So I know 1 times 6 equals 6, and I know 2 times 3 equals 6. I can't think of anything else that equals 6. So I'm going to list them in order from least to greatest. So I have 1, 2, 3, and 6. So I'm going to check to see if I got them all. So 1 goes with 6, and then 2 goes with 3, and there's no numbers between 2 and 3, so I know that I have them all. So because it has more than 2 factors, this number is composite. All right, so let's try 7. Now we just did 7 in our journal, so you should already know this one, that 1 times 7 is the only thing that equals 7. So factors of 7 are 1 and 7, so that makes it prime. All right, see if you can do 9 by yourself. Think of all the numbers that multiply together to equal 9. Then come back and see if you got the same thing as me. All right, so I got 1 times 9. 3 times 3 equals 9, and that's it. So I would have 1, 3, and 9 are factors of 9, so 9 must be composite. All right, so we have 2 more. If you feel comfortable, like you can do these by yourself, go ahead and try them by yourself and then come back and check and see if you got the same thing as me. All right, so I've got 1 times 12 equals 12. 2 times 6 equals 12. And 3 times 4 equals 12. So I have 1, 2, 3, 4, 6, and 12. So this is definitely composite. All right, so for 13, think to yourself of all the factors of 13 and then come back and see if you got the same as me. The only factors that I could think of that equal 13 are 1 and 13. So the factors are 1 and 13, and that means that this number is indeed prime. All right, so for 15. All right, so anytime you feel confident, try to do this by yourself and then come back. I'm not going to keep telling you to pause the video, but I'd like for you to pause the video and do as much as you can and then come back and check. It's really easy to leave out factors, so make sure that you do come back and check carefully. All right, so that 15 equals 15, and 3 times 5 equals 15. So I have 1, 3, 5, and 15, so it is definitely composite. All right, so that 15 equals 16, 2 times 8 equals 16, and 4 times 4 is 16. So I have 1, 2, 4, 8, and 16. Remember, I only have to list the 4 one time, so it is composite. And then for 18, 1 times 18 equals 18, 2 times 9 equals 18, and 3 times 6 equals 18. So I have 1, 2, 3, 6, 9, and 18. So again, it is composite. Let's do 19. The only numbers I can think of that equal 19 are 1 times 19. So the only factors of 19 would be 1 and 19. So it is, and this is a comma, it's just a sloppy one, and that makes this prime. So 1 times 21 equals 21, and 3 times 7 equals 21. So factors of 21 are 1, 3, 7, and 21. So it is composite. All right, 24. 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 equals 24. 6 equals 24. So I have 1, 2, 3, 4, 6, 8, 12, and 24. It's definitely composite. All right, let's look on the back. All right, so find all factors for the following numbers and classify as prime or composite. Explain your classification of each as prime or composite. All right, so factor pairs for 25. So think of all the numbers that you can multiply together to equal 25. Okay, so I'm thinking 1 times 25 equals 5, and 5 times 5 equals 5. I can't think of anything else. So it is composite. And the reason is more than 2. See if you can list all the factors for 28 by yourself and then come back and check and see if you got them all. All right, so 1 and 28, 2 and 14, 4 and 7. So again, this is composite. And there are more than 2 factors. See if you can list all the factor pairs for 29. The only factor pairs I can think of for 29 are 1 and 29, so that means that it is prime. And the reason why it's prime is because it has exactly 2 factors. All right, Brian says all prime numbers are odd numbers. List all of the prime numbers less than 20 in numerical order. Okay, remember, 1 is not a prime number because it has more than, or it only has 1 factor. So 2 is a prime number because the only thing that equals 2 is 2 times 1. 3 is a prime number because the only thing that equals 3 is 3 times 1. 5, 7. See if you can list them. 11, notice that skips 9 because 3 times 3 equals 9. 13 is prime. 15 is not prime. 17 is prime. And 19 are prime. Use your list to show that Brian's claim is false. So I'm going to type this because I can type a little bit neater than I can write with a pen. So I'm going to say, not all prime numbers are odd because 2 is even and 6 is prime. But I'll let you in on a little secret. 2 is the only prime number that's even. The rest are odd, but not all odd numbers are prime numbers. But 2 is the only prime number that's even. Sheila has 28 stickers to divide evenly among 3 friends. She thinks there will be no leftovers. Use what you know about factor pairs to explain if Sheila is correct. Don't you think about that for a minute? We know that if something is a factor of another number, that means that it multiplies together to equal 28. So think to yourself, is there anything times 3 that equals 28? There's nothing, right? So because there's nothing, that means that there will be some leftovers. So I'm going to say that Sheila is incorrect because 3 is not a factor of 28. She will be able to give each friend 9 stickers, 1 left over. Think about it. 3 times 9 is 27. That's as close as you can get to 28, but there will be 1 left over. Right, that was a lot of information today. When you get ready to do your exit slip, make sure that you look at your problem set and remember to always use your journal as a reference because it has a lot of good information in there if you write down everything that I tell you to.